what I want to remind you of several times and up until now, we've always been told you cannot take the square root of a negative number. And that is the true case because any number that you square is always going to be positive. But for math's sake, we have what is called an imaginary number. And our imaginary number is actually I. And what I is the square root of negative 1. So while looking at this worksheet, we have a few definitions that we have to go through. First one is the imaginary number unit, which I just told you I, whose number is whose square is negative 1. So if we have I squared, that equals negative 1. The square root of negative 1 is I, which I told you I is our pattern, or I equals the square root of negative 1. And then we have a non-negative real number x. So if we have that, we have the square root of negative x. That equals the square root of negative 1 times x, which equals I times the square root of x. It's kind of complicated, but something we have to know. There's also something I want you to know, and it's not written on here. I goes in a pattern. So if we have I to the 1 power, that's just I, or what we know as the square root of negative 1. If we have I squared, that tells us right here that it equals negative 1. If we have I cubed, that gives us negative I, so it's also equals the negative square root of negative 1. And if we have I to the 4th, that gives us 1. So it's always going to follow in a pattern, because if you go I to the 5th, that's going to give you I again. I to the 6th is negative 1. I to the 7th is negative I, and then I to the 8th is 1. So if you follow the pattern, you could figure it out. But we do need to keep those down, so kind of write those notes in. But that's the first definition, your imaginary unit, I. So then it gives us some examples, which I already gave you this one just a few minutes ago. We're going to go ahead and do it again. Remember, you can break it up to be the square root of negative 1 times the square root of 81. The square root of 81 is 9, and the square root of negative 1 is I. So we have I times the square root of 9, which this one equals 9 times the square root of I. So it's 9I. Times I, sorry, which is I. Okay? The next one we can break down as well. We have 52 plus or minus the square root of negative 1 times the square root of 169 divided by 13. Alright, break it down even more. The square root of 169 is 13. So I'm going to come down here. We have 52 plus or minus 13 times the square root of negative 1, which we know is I. I'm going to write that in a different color up here. Okay, all divided by 13. And now we can break it down. 52 divided by 13 is 4, and 13 divided by 13 is 1. So we have plus or minus. We don't have to write down the 1. We can, but we don't have to. And then we have the square root of negative 1, which we know is I. So 4 plus or minus I. And that is our answer. So you see how to break them down. You just kind of have to separate your negative away from your actual number that's inside your square root. Number 2 is a complex number, which is the sum of a real number and an imaginary number in the form of a plus b times I. So here we have a complex number, the 4 plus or minus I. In the complex number, your a is the real part and your bi is your imaginary part. So it says, let's look at some examples because I think that's the easiest way to go. It says, write the following numbers in complex form and identify the real and imaginary parts. Well, here we don't have anything that's imaginary, so our number is just 144 plus 0i. because 0 times I is going to obviously give us 0. So your real part is 144. Your imaginary part is 0i. Alright, so example B, you always have to have 0 plus 55i because you have to have two things. You have to have your a and then you have to have your bi. So your real part is 0 and your imaginary part is 55i. This one is already written in complex form, 42 minus I. And so your real part is 42. Your imaginary part is minus I. And example D, we have 3 plus the square root of negative 16 divided by 4. So if we break it down, 3 plus, what's the square root of 16? It's 4. And then I divided by 4. And we can break that down even further because 4 divided by 4 is 1. So that would leave us with 3/4 plus I. So your real part is your 3/4 and your imaginary part is your plus I. So that is your complex numbers. Then we have your complex conjugates. Complex conjugates are pairs of the form a plus bi and a minus bi with opposite signs on the imaginary parts. These solutions to quadratic equations are sometimes these solutions to quadratic equations, which we're going to start working with tomorrow, are sometimes complex conjugates. So find the complex conjugates of the complex numbers. This one is just 144. There is not a complex conjugate because we don't have the I part. The complex conjugate for part B is simply negative 55i. So this was positive, so this one's going to be negative. The conjugate here, we change the negative to be positive. So 42 plus I. And D, we've already worked it out. We found that it was 3/4 plus I is what this is simplified to. So what we can do now, sorry, didn't realize it's off screen. What we can do now is we can just change our positive or our plus sign. So it's 3/4 minus I. And those are your complex conjugates. Alright? Now we have the addition and subtraction of complex numbers. And what we're looking at is the same thing as if we were doing a regular equation and simplifying it. So we're going to take it out of our parentheses. So we have 8 plus 9i minus 12 plus 11i. So we have 8 minus 12, which is negative 4, and then 9 plus 11, which is positive 20i. So that is our answer. The next one, we're going to distribute in the negative sign. And so we have 8 plus 9i plus 12 minus 11i. So that gives us 20 minus 2i. Okay? Next, we're going to talk about the multiplication of complex numbers. It says distribute and collect the terms, the like terms. Remember that I cannot have a power at all, and I squared must be changed to -1. Answers must be in the form of a plus bi. So that's where this little group back here comes back into practice. We can't have a power, so we have to know what they equal. So here we're going to FOIL. 4 times 4 is 16. Our outside is negative 8i. Our inside is positive 8i. And our last is negative 4i squared. So we have 16 minus 4 times I squared is -1. So we have 16 plus 4. So our answer here is 20. And then we have the next one. We're going to FOIL it again. Negative 6 times 5 is negative 30. Then our inside is going to be plus 18i. That's our outside. Our inside is 10i. And our last is negative 5i squared. So we have negative 30 plus 28i minus 5 times -1. So we have negative 30 plus 28i plus 5. So we have negative 25 plus 28i. So your assignment, part of your assignment is going to be to perform the indicated operations. And then we're going to look at computations with a graphing calculator. So let me get my graphing calculator and we'll get started here. Alright, computations with the graphing calculator. What you need to do is you need to set your calculator to the mode of your complex numbers. So what we're going to do is we're going to change it real quick. Turn on your calculator, go to mode. Scroll down to where it says real. Most of y'all's will say real. Scroll over to where it's flashing above a plus bi and hit enter. And then it's set to your complex number mode. Now, I'm not going to use this paper to actually do our problems. I'm going to do them on a different page. We're going to start with 3, then do 4, and then do 1 and 2, because I think it's easier to start with 3 and 4. So what I want you to do is I want you to look at finding the reciprocal of 4i. So I'm going to get out of this screen. When we're told to take the reciprocal of a number, we are told, or we know from math, or you should know, that that is that number to the negative 1 power. And so what I'm going to do is I'm going to put my 4i into parentheses. So 4, your I is above your decimal point, so hit second decimal point. And then I'm going to hit to the negative 1 power, which is right here on your calculator below math. And I'm going to hit enter, and it gives me my answer, negative 0.25i. So your the answer to the reciprocal of 4i is negative 0.25i. On the next one, the reciprocal of 2 to the negative 5i, we're going to put 2 minus 5 second I into the calculator, and then to the negative 1 power, and hit enter. And so your answer is, if you look at your calculator, get it out of the glare, I'm sorry, 0.069 plus 0.172i. So that's your answer there. So that's how you find the reciprocals of those numbers. Now if we look to number 1, it was 3 plus 7i divided by 2i. And what we have to do is we have to take the reciprocal of the 2i and multiply it times your numerator. So if you have a fraction or if you have a division, you take the numerator and multiply it. You multiply it times the reciprocal of the denominator. So what we're going to do is we're going to do 3 plus 7i times 2i, the reciprocal of 2i. Okay? So we're going to do that in the calculator right now. 3 plus 7i times 2i to the negative 1. And we get our answer, 3.5 minus 1.5i. So that's pretty easy to look at. We just have to remember, like looking at number 2, if we're wanting to do division, we're going to multiply the numerator times the reciprocal of the denominator. So let me put that in my calculator. 4 minus 3i times 2 minus 4i to the negative 1. And that gives me 1 plus 0.5i. And there we have our how to do computations in the graphing calculator. So your assignment will now be numbers 1 through 8 under perform the indicated operations right here that we marked earlier, and the back numbers 1 through 28.